volume, and we did the whole with water, right? How many pyramids fit into a prism? Three, good, okay. And how many cones fit into a cylinder? Three. So we're going to do a similar thing today. We're switching these 2 days today. And so this is going to be, we're doing this today, Wednesday, 5/28. And this is going to be Thursday. Okay, so 5/29. So we're just sort of switching these two around. So we're going to do this, volumes of surface area and spheres today. So 12.5. So here we go. We want to start talking, so more with volume to get started, but we're also going to talk about some surface area today. And so we want to compare the volume of a sphere with a cylinder. And again, I have a little water demonstration here. And so we want to know, today we have a cylinder which has a radius r. And we also have a sphere which also has the same radius, okay? Also, that it's the height, this like the radius straight up and straight down matches the height of this cylinder. So 2 r's, it is 2 radiuses tall, okay? So they're sort of the height of each are the same. And so it turns out that I have a hemisphere here somewhere. Here we go. And I have my, here it is. Here's my cylinder. And so I have my cylinder and my hemisphere. And we're going to compare the hemisphere. What is a hemisphere?
Like the Earth, like the circle around it.
So here's the sphere, right?
A half circle.
It's a half of a sphere, yeah.
Oh,
So a hemisphere is just half that circle. So we're going to compare how many hemispheres. So how many hemispheres equal the one cylinder of these sort of measurements. So how many hemispheres equal one cylinder? And we're talking about volume. So what is a hemisphere?
Half circle.
Half
Sphere.
Okay. So so we're looking at half the volume of half a sphere. All right. So we want to know how many the volumes of half a sphere, that would be the hemisphere, is equal to the volume of one cylinder.
Equals 1 up.
All right.
Wait, why didn't they just call it half sphere?
Half sphere. Well, you can. Hemi means half.
Wait, hemi means half?
Yeah, so like a hemi truck, it's a half ton. Okay.
Hemi truck and
yeah, half ton truck. Yeah. All right. So we're gonna play our little water game here. Oh, I'm going to. You're not gonna. You guys don't get to have fun. It's just me.
Wow.
All right. So, what are your guesses? How many of these hemispheres are going to fit inside? Three?
3 or 4.
3 or 4? All right. Let's see. So, I haven't practiced this one, you guys. So, I got to make sure I get to the line. There we go. All right. 1.
Definitely 3.
What are we thinking? 3, 4? Okay. It'd be interesting, I guess, like yesterday's 3, maybe. That would be nice. 2? Are we 3, 3.5? All right. Come on. There we go. It's a little bit under. Let's see. Okay. I was a little bit shy when I was pouring. Anyway, it should be 3. Okay. 3, yeah, it seems to be a lot of 3s here, which is kind of interesting. So it does turn out that 3 hemispheres equal the volume of one cylinder. So what I'm going to do, and this is what I love about geometry, is we're going to come up with the formula. And it comes just by these little things that we were very observant once upon a time. We are not so observant in the 21st century. So we know how to find the volume of a cylinder. What was our formula for the volume of a cylinder?
1/3.
Area of the base times the height, right? So that was capital B times the height to find the volume of a cylinder. Well, the area of a base, what shape is our base here of our cylinder? A circle with radius r. And how do we find the area of that circle? Pi radius squared. Great. So what we have then for the area of our base, we have pi r squared, because that's what our base is. And then we also need to multiply it by the height of our cylinder. And what is the height of our cylinder? 2r's. Okay. So twice the radius, as I said before. I'm going to clean that up again. Let's see. So then I have three half spheres. Can I write that as 3 halves of a volume of a sphere? Do you think that's the same thing? Yeah? So 3 times a half would be 3 halves. Okay. Let's see. And so I'm going to clean this up. What is r squared times another r?
R to the third.
R to the third. And so I have 2 times pi times radius cubed to clean up this right-hand side. That's kind of interesting. And that's equal to 3 halves the volume of a sphere. And this is what we're trying to figure out. We don't know what the formula for volume of a sphere is, so I want to get this volume of a sphere by itself. How can we get rid of the 3 halves?
Multiply by 3 halves.
Multiply by 3 halves or multiply by 2/3?
2, 3, 2.
Multiply by 2/3. Yeah, it's multiply by the reciprocal. If I multiply by 2/3, we would get 6/6. And what is 6/6? 1. All right, so that's how that cancels out. I have to do it to both sides. So I'm going to multiply both sides by 2/3. So this cancels out. We get 6/6, which is 1. So that goes away. Leaves us with the volume of a sphere equal to, look at here, we have, this is 2/1. And so to multiply fractions, you just multiply straight across. So it's 2 times 2? 4. What's 1 times 3? 3. 4/3 pi r cubed, ladies and gentlemen. So the volume of a sphere is 4/3 pi radius cubed, which is quite interesting. But hey, we did this all by ourselves, right? This is where these formulas come from, you guys. We relate things to one another, and magically we get this beautiful thing, okay? And that's what's, I think, very cool about geometries, all these things. So now that we have a nice little formula, we can use that formula in all sorts of ways. So letter A, find the indicated measure. What is the volume of a sphere with the radius 9.9? So the radius is 9.9 feet, rounded to the nearest tenth. What's the formula for volume of a sphere? Say it out loud. 4/3 pi radius cubed. Ladies and gentlemen, when you say stuff out loud, you're going to remember it better, okay? Keep that in mind. And so what are we going to do? Times 9.9 cubed. Very good. And you're going to get a calculator and you're going to plug that in and round it to the nearest tenth of a cubic foot. All right. So 4/3 times pi times 9.9 to the third. The little caret guy right here, that little caret guy gives you your power. Okay. And I get 4064.4 if we round up. This is volume. We had feet, so they are cubic units. So 4,064.4 cubic feet. All right. Letter B. What is the volume of a hemisphere? What's a hemisphere?
We just do that and just divide by 2.
Yeah, it's just half of a sphere. All right. And so what we're going to do is I'm going to take the volume, and I just want half the volume of a sphere. And so I'm just going to put a half in front of my formula for the volume of a sphere. What is the formula for the volume?
Pi r.
4/3 pi radius cubed. And we just want half. All right? Could you just take your answer and divide it by 2? Sure, that's another way to do it. Okay. All right. Let's see. And we have, diameter of 5.5. Okay, the diameter is 5.5. That means the radius equals 2.75. Okay, read carefully, please, ladies and gentlemen. We need a radius, not a diameter. All right, and so we want to just do half of 4/3 times pi times our radius cubed. All right. So I'm just going to do 1/2 times 4/3 times pi times 2.75 to the 3rd power. All right? Not complicated. Do you notice that I don't do the silly fraction thing that you guys do?
Why?
Because it takes too many extra button clicks. Like, I'm lazy.
Super fast.
Okay? No, it's super horrible. This is 2 clicks. Yours is 4. Okay, I'm all about efficiency. All right, we get 43.6, and that's centimeters cubed for the volume of our hemisphere. Okay. Lots of ways to do this, but read carefully, I think, is always a good thing. All right, letter C. What is the radius of a hemisphere? Ooh, interesting. What is the radius? What are we trying to do here? Yeah, we got to find R. So we're solving in this. We need to find the radius of a hemisphere with a volume of that big giant number. Okay. Well, what do you guys think? What should we do? Okay. So we know that our volume of a sphere is 4/3 pi radius cubed, but that's the volume of a sphere, but I have a hemisphere. How do we deal with that?
Divide by 2.
Yeah, 1/2 or divide by 2. So I'm just going to pop a 1/2 in front because we know a hemisphere is half of a sphere. All right. And so we can plug in, what do we know? What are we going to plug in? The V. Yeah, we have this big number for volume. The volume is 81,449. So that's what we're going to plug in. 81,449 equals, I'm going to clean this up a little bit. 1/2 times 4/3. We just multiply straight across here, and we're going to get 4/6 pi radius cubed. So just to clean that up. All right, now we need to solve, ladies and gentlemen. How do we solve? How do we get R by itself? True, which is a little bit weird. I'm going to take it one at a time. How do I get rid of this fraction 4/6? Multiply by 6/4. Okay, I'm going to do that first just because in my calculator that's going to be a little bit nicer. Multiply by the reciprocal. If I multiply 6/4 times 4/6, I'm going to get 24/24, which cancels out to 1. All right. Over here on the left-hand side, I can do 6/4 times 81,449. And that gives me 122,173.5. Crazy. Equals pi radius cubed. Now what do you want to do? Divide by pi. Sure, let's divide by pi. So that cancels out, and I can do that in my calculator. Again, I'm just going to divide by pi, so it pulls in my answer. I get something crazy. 38889.0328. Do not round until the very end, ladies and gentlemen. We do not round in math until we are completely done. So we have this crazy decimal. How do we get r by itself when it's being cubed? A cube root. Very good, yes. To cancel out a power of 3, we need the cube root of both sides. The cube root and the cube undo one another. Where in our calculator do we find a cube root? Math. So we're going to go to the math menu. And the math menu, number 4, is a cube root. All right. And then I just want to call in my answer. So I'm going to do second answer, which is at the very bottom in blue, and that's going to pull in the previous answer. Yep, so we get 33.879, which is going to round to 0.9. And there's our radius of our hemisphere, okay? So use those buttons, use the answer, learn how to use the calculator. It's important. Questions on letter C?
No.
Okay. All right. All right, let's turn the page. I don't think I want to do D right now. Okay, so now we need to talk about surface area, which is the wrapping that goes around things, right? How we wrap it up, how much paper do we use when we wrap something. And I kind of like the graphic here for the surface area of a sphere. When you think about a baseball is sewn together. It's 2 pieces of leather that's been sewn together, which is really kind of interesting. I don't know if you've ever studied a baseball. I really hadn't looked that closely. But yeah, it's really just 2 little pieces of leather sewn together, which is kind of interesting. And if you take that leather off the surface, you can see that it's kind of close to looking at just the area of a circle. And how many little circles of the same area do we have? 4 of them. So it turns out that the surface area of a sphere, so SA stands for surface area, is that we have 4 of these just area. Like this is just the area of a circle, and we have 4 of them. What is the area of a circle? Pi radius squared. So we have 4 pi r squareds, and that's it. So the surface area of a sphere is simply 4 pi radius squared, which is kind of interesting. And so I really like that picture because maybe it's going to help you remember later on, well, it's just 4 little circles, right? And that might be something we can remember for later. Okay, so then I want to talk about, what about if I have a hemisphere? What is the surface area of a hemisphere? So I'm just to draw a hemisphere. So So is it just half? It is half. It's a hemisphere, so it's just half of a circle. So part of it is just the top piece. Let me get my hemisphere here. It is just half of a circle. So the surface area of this crown would just be half of our surface area here. That's true. So this surface area is just going to be half of what we just found, 4 pi r squared. Okay, it is, because it is half. However, yeah. However, that's only the top portion. That's only this top surface of the circle, and the problem is there's another surface now. When we're talking about surface area, we have to include all the faces. So we have this flat portion, So I need to include the surface area of this green part. So I have to add this extra surface. And what's the area of this green thing? Pi r squared. Yeah, it's just another circle. So plus pi r squared, which is the base. It is that bottom piece. And so it's two parts to think about whenever we talk about surface area. There's lots of spaces. So we have the top portion here, which is just half that sphere. And then we have this base piece, which is, in this case, the green section that we need to add to it. So as you were saying, Carl, what is half of 4 pi r squared? 2. Yeah, 2 pi r squared. Plus 1 more pi r squared. So it is just 3 pi radiuses squared. So the surface area of a hemisphere is 3 pi r squared, which is kind of interesting, isn't it? All right. I thought that was pretty interesting. I had never actually used it before, but it comes up these days. So what are you thinking, Carl? No. The powers only change when we multiply, not when we add. So, yeah. So you can think about it as 2 pi r squared plus 1 more pi r squared is 3 pi r squared. All right. So we've got the surface area of a sphere and the surface area of a hemisphere. Now we need to think about the surface area of a cylinder. Okay? So here we have our cylinder, and I want you to think about a soup can. The soup can has a couple of features. It has a top and a bottom. All right, what shape are the top and the bottom? Circles, okay. And so we know the area of these circles. What are the area of each of those? Yeah, it's pi r squared. That's the area, and pi r squared. So there's 2 of them. You're absolutely right. So we have a top and a bottom, and then we have the wrapping. And on a soup can, that's the label portion. And what you want to think about is when you unroll that wrapping around a soup can, it's really just a rectangle. All right, and so it has a height of whatever it happens to be, and then the length of this, it wraps around a circle, so the length of this rectangle is equal to the circumference. Very good. All right, it is the circumference around that circle. What's the formula for circumference? 2 pi r, very good. 2 pi r.
Measure the circumference of a can by just taking off the label.
Yeah, exactly. You can measure the circumference of a can by just taking off the label. It's brilliant. So if we want to find the surface area of a cylinder, it is equal to, it has 2 circles, so there's 2 pi r squareds plus our rectangle, and the rectangle is, the area of the rectangle is just the circumference, 2 pi r, times the height. And so if you really want to clean it up, it's 2 pi r squared plus 2 pi r h. And so that's the surface area of a cylinder. And again, these are things that if you have an understanding of how it's formed, is it something you have to memorize, or is it something you just have to think about? Hopefully it's something you just have to think about. And maybe, you know, now that you've seen the net for a cylinder, it's not too hard. You don't have to memorize it because we can just think about it and build it. All right, so let's look here. Example 1, if the radius is 6 centimeters, find the surface area of a sphere. The surface area of a sphere is 4 pi radius squared. And all we have to do then is plug in our radius. 4 pi times 6 squared. Ooh, yeah, so 6 squared times 4. I'm getting 144 pi. Could I leave the answer in terms of pi? I sure could. That's a great answer. All right. Can you just divide this by 2 to get the surface area of a sphere? Hemisphere? No, not that simple. Remember, when you have a hemisphere, you have to also include the base. So there's extra little bit. So do be careful. Let's see. If r equals 4 and the height is 7, find the surface area of a right cylinder. So we have a radius of 4 and a height of 7 to get our cylinder there. All right, so the surface area of a cylinder is 2 pi r squared because we have a top and a bottom, plus, the circumference times height for the area of the label. All right, and all we have to do is plug in our stuff here. What's our radius? 4. And 2 pi radius of 4 and a height of 7. So, big stuff there. Lots to plug into your calculator, really. 2 times pi times 4 squared plus 2 times pi times, can I just say 28? Yeah? Okay. So our surface area of a cylinder is going to be 276.5. And this is centimeters. What are the units for surface area? Centimeters to what power? Squared. It's area, not volume. Volume is cubic. Area is square units. Okay. Oh, we can't answer C yet. We had to skip that. Let's look at, you don't know the surface area of a cone yet, so we're going to skip that. I had to, rearrange some things, but that's okay. Find the surface area of the silo. Let's talk about the surfaces. If you want to find surface area, you got to talk about the surfaces. Oh, man. So we have this hemisphere, SPH. We have half a sphere here. Do we need to include the base? A surface area, when we're finding surface area, it is the outside. So do I need to include this little base in here? No, we do not. It is not an outside piece. It is not an outside area. So all we have to do is the top there, which we said was half of a surface area of a sphere is just the outer portion. So that's what we want, which is just going to be 2 pi r squared. Plus, we need this label, if you will. I'm going to just call it the label of the cylinder. Let's see here. What is the radius that we're looking at? 11. Okay, so the 11 is the radius. And if 11 is the radius, the label is going to be circumference times the height. All right, so 2 pi r times the height. Now this is the tricky part. So that's the label. Label, L-A-B-E. I don't know how to spell label all of a sudden. Okay. Is the height of the label 45? No, it is not. Yeah, 45 is top to bottom, so we need to know the height of just our label here. How do we figure that out? What did you say, Carl? No, actually, we know from the bottom to the very top here is 45. Yeah, we just have to subtract 11 because that radius goes right to the top of our label there. So 45 minus 11 is 34 for the height of the label. All right, so that's important to realize that that height is going to be 34. And then the last thing that we need is this base. We do need the area of this bottom piece. So plus the very base, there's only one circle at the bottom, and that area would be pi r squared. Okay, so when you're thinking about surface area, you're just really having to think about all the little parts that make up the figure, okay, the outer surfaces. So we have 2 times pi, our radius is 11, that is the half sphere. And then our label is going to be 2 pi times 11 times a height of 34. And then our base circle is pi times 11 squared. And if we add all of that up, we're going to get 3490.3 for the surface area of that composite figure there. Okay. So be careful when doing these. Really have to look at all the little parts that make up the figure. Do you have any questions for me? Okay. All right.